today. I'm Andrew Lockhart, the Vice President of Marketing. Our topic today is how to create disaster recovery protection for your multi-tier applications. We're going to try to keep this a technical discussion, and so you're not going to be hearing from me. What I'd like to do right now is introduce you to Mike Hamilton. He's the Director of Client Services here at nScaled. He's personally involved in every client implementation that we do, and he's got a lot of great stories to tell us, from the trenches, as it were. And the subject today, as I said, is protecting multi-tier applications. So, Mike, let me hand it over to you and start off by asking you, what are multi-tier applications, and why are we having this discussion today?
Great, thanks, Andrew. So, multi-tier applications, when I was originally coming up with an idea for what to talk about in a solutions brief, I thought I'd go broad first with multi-tier applications because it covers so many different things. You know, brand names would be things like SharePoint and Autonomy, Alfresco, products such as that. But the reality is that it's really any type of a software application that can have multiple servers involved in it, each with a different role. And in some cases, like one server will have more than one role installed on it, but the bottom line is that the roles are spread out across multiple compute nodes. And so you might have a database layer, an application or an API layer, a web layer, you might have an indexer or a file server. So that's basically the overview of what the architecture is. And so what we'll talk about today is how do you protect these? Like, how does DR work with these kind of complex systems? And why is it important to look at these? Why is it important to give extra attention to these? So again, with the architecture talking at the top layer, you might have some load balancers, and then down from there you usually have some application servers. You may have an application server, you may have an API server. Depends on the way that they might call it a web server and then an API server underneath that. But there's usually some kind of an application layer. There's an API layer, and then there's a database layer. Sometimes the database layer is clustered. It's usually based on what you can afford. So why is it important to talk about disaster recovery for multi-tier applications? What's the big deal here? The big deal is that typically the reason that an application supports a multi-tier architecture is for redundancy and high availability and spreading out compute load. So in other words, this is an application that's so important to your day-to-day operations that you've actually had to spread it out across multiple servers. You've got a high user demand. You've got a high high I/O demand, or you've got high availability. You need to be able to work on the servers and be able to sustain an outage, for example, of a single server, but not lose any uptime at all. So if they're business critical, chances are it's the most important thing for you to protect. It's the most important thing for you to have a disaster recovery plan for. And so, building upon that, let's talk about what do you actually have to protect and what are the challenges. So let's talk about the way that we approach protection in the first place. So we use a technology called block level mirroring, and basically the way that works is that you have an agent installed on your hosts, the guests actually, if they're virtual machines, or the hosts if they're physical hosts. It doesn't matter in our case. It can even be a cluster, and this agent will work just fine. The agent actually does what's called write splitting. So it takes a write operation that's going for local storage, and it actually splits it off to another disk. We call it a mirror disk. And so basically, if you think about it, the way that works then is that every write operation that happens on a server is mirrored to a second disk, almost like RAID, but it's done at the software level. Now, the key here is that we're not just mirroring the blocks, though. We're also going to take a snapshot of them. So if you can picture in your mind this mirror disk that's sitting on, in our case, a local cloud appliance, which is an appliance we provide as a part of our solution, all of the latest write operations are being done to this mirror disk. And the old values, though, are kept. What they do is they push those old values down into a bucket, and then when you take a snapshot, the bucket is essentially closed, so that you have point-in-time views of your server, but the latest version of your server is on the mirror disk. And this allows you for quick local recovery for one. So in our solution, you can actually recover a single node off of the local cloud appliance directly. But the other thing that it gives you is highly deduplicated snapshots. So because we're only storing the deltas in the snapshot buckets, they're very, very deduplicated. It's only the deltas between snapshots that are collected in those buckets. So one of the keys, though, is quiescent snapshots. Because when you wake a server up from this type of a protection scheme, you actually need it to be able to boot, and you need the file system to have its integrity in place. And so for a typical server, that involves having a file system agent installed. The file system agent actually makes sure that the file system is aware that a snapshot is being taken and that the block level changes are represented in the file system. That way, if the server wakes up in a disaster situation, you're recovering from a disaster, the server wakes up, it knows that the file system was actually in the consistent state when the last snapshot was taken. This also allows it to boot. Windows is not going to boot if the file system has some kind of a problem. The latest block level changes were not recorded, and therefore the server's in an inconsistent state. So quiescence is key. But another thing about our technology also is that we have SAN independence. So in multi-tier applications, in a lot of cases, what you'll have is you'll have some kind of a SAN resource that's being shared between servers. If you're using a database cluster, you probably have, in fact, you have to have a SAN resource shared between the cluster nodes so that you can actually fail over between cluster nodes when you need to do that operation. A lot of other servers require some kind of iSCSI target that's shared between them, or maybe they require a CIFS target that's shared between them. But the idea here is that we can snapshot those as well, and we can protect them locally. So this gives you the ability to recover locally. What we do with that mirror data and what we do with the snapshots, though, also is that we replicate those offsite into our cloud environment. So this gives you both local recovery and remote recovery of your environment. So that's the basic premise of our server protection model and how we handle server protection. Let's go a little bit deeper, though, into how this applies to multi-tier applications. So I coined a term, and the term that I coined is called cross-server application quiescence. And the idea behind cross-server application quiescence is that in a multi-tier application, you have a state across servers that needs to be preserved. You've got a database that has pointers probably to a file in a lot of cases, and those pointers need to be current. They need to be in the same state. And so cross-server application quiescence is about looking at the whole application stack and saying, if I have an actual failure, which piece of this needs to be in front of another piece? Or, so is it okay for the data? Is it better for the database to be a newer version than the file system that I captured for where the files are located? Where does the indexer need to be in terms of this order? And actually, the vendor will tell you, in terms of the backup and recovery and disaster recovery process, what that needs to be. But for a lot of cases, like, for example, document management, the database needs to be, it's actually better for the database to be behind the file store, for example. What I mean by behind is that in terms of time, it's okay for the database to be older than the file store because you can actually essentially diff those and figure out what's missing. But it's not good if the database is ahead of the file store because the database has invalid pointers. So the database is actually pointing to files that don't exist anymore, and therefore it's not really a valid look at the whole application. So what is this about? This is about timing, right? So let's say, for example, that you want to ensure the most flexibility on this. You want to make sure that you've got the best recovery options. You might snap the database every 15 minutes, and then with a 5-minute offset, snap the file system to make sure that you've got a couple of options so that you can always differ your snapshots by just enough to know. And this would all be based around your recovery point objective. So your recovery point objective, for example, is how much data are you willing to lose in the event of a disaster. So let's say that your recovery point objective is 30 minutes. You can sustain 30 minutes. In a multi-tier application architecture, it's probably better than to actually snap 15 minutes in most cases. If your goal is 30 minutes, it's typically better to snap about twice as often as your recovery point objective would dictate. And the reason for that has to do exactly with the cross-server application quiescence, trying to make sure that the data across servers is in a usable format so that you don't have a case where there's data missing from one piece that will cause the application to have problems. Maybe it's a case where the database has to be first, so you need 15-minute snapshots of that, but the indexer can be much more out of cycle. Either way, this is something that you want to plan as a part of your disaster recovery solution. So you want to know what has to be the most frequently snapped and what has to be the least frequently snapped. And one of the interesting things about multi-tier applications is that something like an application server, you can probably snap daily in a lot of cases. You don't even need a lot of granularity because a lot of these type of applications, they have pieces that never change. They don't hold any unique data. They only change if you patch the solution. And so part of the way that we have an approach to that is that we might only, we might snap that one hourly for a day, for example, and we might retain like 3 or 4 days of an application server. But that's about it. Whereas you might be snapping your database server every 15 minutes and retaining, a couple of weeks worth of those snapshots. So from an architectural standpoint, that's really the key component of the design, is planning your snapshots, planning your recovery, and then having a documented process for recovery. So it's one thing to talk about it and say, okay, this is what we're going to do, and this is how we're going to recover it, but then what do I do? Well, I need to document it so that I know that we've already gone through the process. We need to be able to test this. We need to be able to go through the process, and we'll talk a little bit more about testing as we move forward. One more thing that I wanted to talk about before we change slides, though, is a recovery time objective. So after you've considered your recovery point objective, you've figured out that you can lose 30 minutes of data, therefore I should probably be snapping twice as often as I would normally snap, just to make sure that I have enough granularity to deal with the application when it wakes up in a disaster. The recovery time objective is another piece. So again, with multi-tier applications, usually your business is somehow heavily dependent on this system. It needs it all the time. Your business continuity is critical to the day-to-day operations. What about recovery time objective? How long can it take? How long can you be down before you need to be up and running again? And another thing that you can architect with this is how much do you have ready to go? So locally, for local recovery, if a single node fails, you're probably going to change a couple of pointers. You're going to change, your load balancer might point to a different application server. You might bring the application server, the failed application server up under the same IP address. Usually that kind of stuff's really easy to change locally. Again, you should document it. It's important to have that in a run book. But what about remote recovery? How do we minimize remote recovery when you've got to go to the cloud? So part of the approach that we do in implementation is that we predetermine with you, when we're going through the implementation, what kind of external IP addresses do you need? What kind of VPN connectivity do you need? Do you need end-user VPN connectivity? Do you need, in other words, if you have a major disaster and your people are working from home, it might be the best to just have them VPN directly into the cloud data center and not even go through your data center. What kind of servers should be running full-time in preparation? Maybe it's a case where what you want to have is a load balancer deployed in the cloud data center, even if it's powered off, but it's pre-configured. You want to have the NAT entries, which is something we do with you, already set up. The public IP is already set up, knowing which A records you're going to change in your external DNS and having that already set up. So that in the event of a disaster, you can get your recovery time down to minutes because you've got as many pieces of this working as possible. Another example is one of the benefits of these application servers is because they don't change that often, if you really want a tight RPO, you could leave the application server running all the time in the cloud environment. We only really charge you for RAM. There's some storage costs in our pricing model, but we charge by the terabyte for storage. So typically the application servers you can use a very small amount of storage, therefore it doesn't really impact your overall pricing. So there's no big deal in just leaving it running all the time. It gives you an easy testable scenario that you can run through, and the server is ready to go. So really then it's just down to these layers like the file server or the API server or the database server that you've got to recover in the cloud, and you've got to recover on short notice. Go and go to the next slide. Yeah.
You mentioned document management systems as an example of these multi-tier applications. Are there some other really common multi-tier apps that you encounter with our customers?
Well, things like SharePoint are really common. Learning management systems are really common to have multiple tiers. Accounting systems, Elite, for example, is a huge. We have a customer with a very large Elite installation. They have a database cluster with 14 LUNs. Since they have a cluster, they actually run more than one database off of the cluster, so that cluster serves multiple applications. But in their particular case, also, that multi-tier application actually spans a bunch of add-on applications as well. So there's the core application, which has about 9 servers associated with it, and then there's another 6 or 7 servers associated with all the plugins that they can use and all of these different components that they can leverage of the application. And we've actually protected the entire system and shown that it can be brought back up in a disaster. It's fully documented.
Right.
So yeah, they can get arbitrarily complicated.
These aren't like weird and exotic applications. I mean, you're talking about very mainstream things like accounting and SharePoint. Okay, great, thank you.
Yeah, and one of the reasons why that's important is that somebody may have their own application they've developed in-house that does have some idiosyncrasies, but the benefit of our approach is that we've encountered a lot of these bigger systems already, and they're common for a reason, is because they work, and companies like to leverage them, and they scale for a reason because other companies have bought them and had to scale them up. So, thankfully, it's not like we're encountering strange applications in the wild all the time. Most of the time, we've seen these before, or we have some experience with them.
Got it. Okay, thanks.
So, the other part of the disaster recovery plan, and this is where a solution, or the nScaled solution is just a really, really slick way to go, is that we give you the ability to know where are you right now with your disaster recovery solution. So we have dashboards that tell you, how's your RPO looking? Are you going to hit your RPO if the disaster were to strike right now? How's replication going? We give you the ability to test your recovery time objective, and I think this is the most important component of it, is testing your recovery time objective. So a lot of do-it-yourself, when I encounter people with big systems that are thinking about doing disaster recovery themselves, usually it's because they've been in a discussion with a SAN vendor who's saying, yeah, we do everything, just put this SAN here, this SAN over here, and you're done. And that's not exactly true. In most cases, what I've encountered, both personally and professionally, is that you typically don't have a lot of time to do disaster recovery testing if you've already got to build the disaster recovery system yourself, and then documentation usually gets left out in the back and it doesn't get done effectively. So going through professional engagement with nScaled to get your disaster recovery needs met means that you're going to have documentation, you're going to have an environment that works, you're going to have monitoring that'll tell you if there's something that's not going correctly with your implementation. But most importantly, it's giving you an environment to test that's sane. So one of the problems with testing in your own environment is typically you're going to end up testing you're going to have to test a production system. So you're going to have your disaster recovery set up, your secondary site, whether it's Colo or one of your other locations, and you're going to end up testing your own environment, which means production, which means after hours, which means scheduled maintenance. And that's a hassle for everybody, because one of the things that's really common with multi-tier applications is that you're not the only one. It's not just the IT staff that has to do the testing. You've got to have the application owners, which means I know in one test where I've participated in a test with a client, it was 14 people on a call for 4 hours over a weekend, to make sure that the application worked, because the IT staff doesn't know how the application works and how to fully test it. So, testing these type of things in after hours is just a hassle. It's a lot of overtime. It's a lot of people's time away from the office, away from their families. At nScaled, we have the test environment already worked out. The first piece of it is that we leverage an Active Directory domain controller. So your cloud environment anyway will have an Active Directory domain controller running full-time. Our cloud environment is another site in your AD sites and services. When a server wakes up in the cloud environment in a real disaster, it registers with the Active Directory server, registers with DNS, and those A records replicate back into your environment, and users are automatically pointed. But test mode, what we also leverage that Active Directory domain controller for is for test mode. We can snapshot that domain controller. We can fire it up in test mode, which is an isolated VLAN. This gives you, it's an isolated VLAN that you can actually access. We can have you access from the internet. We can have you access it from inside your network. But the bottom line is that it's isolated from the standpoint that your production systems don't have to be taken down. There's no replication that's going on. There's like no AD replication. Nothing is going back to your environment that's going to cause a substantive change, but you can actually fully test your environment. So what does this let you do? Well, first and foremost, it lets you create the documentation with us. We sit down with you, we have a template that we run you through what you need to have to make a successful runbook. But it gives you the ability to also periodically test your DR environment during business hours. So you could say, for example, in fact, this is what one of our clients has done. The IT staff was blocked out for this period of time to test the disaster. And then from this other block of time, the application owners come in and they do their application testing. And then the whole environment, maybe they leave the environment up for a day just in case somebody comes up with some idea like, oh, shoot, we should have tested this. And then you tear it down and you're done. So think about the amount of time that saves. Like, let's just say that your IT staff involved in disaster recovery plus your application owners is 15 people, let's say. Thinking about how much time that spends and how much that costs just to do disaster recovery drill after hours, it's a pretty insane number when you think about the per hour cost. But if you look at what you can do with this, we've got this whole environment set up for you. We do this every day, and you have support. You can call and say, hey, you know what, I need some help with this. I need to know, how we can leverage this feature, or I'm not clear on something, and that's what support is here for. But another key of also having support for your disaster recovery, your disaster recovery plan, is we keep a copy of the runbook, and the benefit of having that is, let's say, for example, that during a disaster you just don't have anything. Whatever took out, if a hurricane took out the power grid in your area, or some other disaster took out a power grid, and you actually don't have network, you can't get anywhere to get any work done, you can actually call nScaled and say, okay, I'm stuck, I don't have people in other offices, but people are going to want to start working as soon as possible. Can you fire up my environment and start, work off the runbook and get it going? And that's what we're here for. That's another benefit of having our support. So really end to end, the nScaled solution can support you. And I can't emphasize testing enough. The ability to test your disaster recovery is just critical because it's one you'll forget over time. You know, like, oh yeah, what do I click, or how do I do this, or what was that? Another benefit of disaster recovery testing, and another reason why it's important to come up with a runbook, is that you find these idiosyncrasies, such as the original sysadmin that worked on this system hard-coded an IP address into this config file. And without testing disaster recovery, you don't know that that was done. And therefore, you don't know what to change. You know, maybe you need to change it in production to use a DNS name. Or maybe you just need to note that, like, well, it's more efficient to use the IP address, but we do need to change the IP address in that config file. It really gives you insight into your own environment because you're deliberately taking it apart and putting it back together again. But it's so nice to work with the safety of having the latest snapshot of your data, the latest version of your servers, and being able to say, hey, you know, let's go ahead and fire this up in a safe environment. Let's test it during normal work hours, and then we can tear it down when we're done.
Yeah, you know, Mike, you and I talk about testing all the time, and we write about it on the blog all the time. And you know who else has been writing about testing in terms of disaster recovery is Gartner. Their analysts who cover disaster recovery have been presenting at conferences and talking about all the problems with sort of traditional disaster recovery where you have, you know, replicas of everything, and they make a big deal out of the fact that every time you patch your OS or upgrade your application, you know, think about how many times you do that in a month across all your apps and how quickly and badly your recovery site can fall behind and be and you know, and in our discussions with those analysts, you know, we say, look, you know, with our block level replication approach, that's just a non-issue, right? You don't have to, you know, test that you've got the right version of the app, you know, as your recovery target, because that just happens automatically.
Exactly, and another important piece too that we usually talk about in the process of engaging with a customer is testing things like upgrades. So let's say that you want to know, will this version upgrade of this accounting server or document management system, is it going to go smoothly? Do I have a ballpark idea? And if you've already done, you already know how hard it's going to be activated in test mode and how close to your recovery time objective you're going to be able to actually get. It's also nice to be able to use the test environment to say, hey, let's try the upgrade of this and let's see if it, you know, what kind of snags you run into. So you follow your run book again to get the environment up in the disaster recovery environment, and then you just test application upgrades. One of the points that I make in the solutions brief that I wrote around multi-tier applications is that recovery time objective, first of all, it's an objective, but second of all is that it's a very nebulous number if you don't have something to test against. So it's one thing to say, I think I can get this application up and running in an hour, but it's another thing to actually know that you can get it up and running in an hour. And you need to actually get your disaster recovery plan as closely aligned with your business objectives as possible, so that the business side of the house is saying, your RTO has to be under 60 minutes for the system, or under 30 minutes, let's say. Then it's important to have an environment you can test to determine if that's actually a number you can reach or not. And maybe it is. You know, obviously it usually costs more to do that, although actually with our solution it's not really that much more expensive to have just live running servers, for example, if that's the most time efficient way to do it. But having the testability is key, because then you can also report back to your business owners, you know, like the chiefs of the organization, and say, hey, we just tested it yesterday and your RTO was 1 hour. We did it in 50 minutes. So we know that we can do it, and these are the people involved, and they're up to speed, and you know, it's something you can actually report on, as opposed to this nebulous number, because it's not an absolute figure. Recovery time objective is not something that can easily be calculated. It's sort of a dance between your business requirements and what you can actually deliver. And so it's really nice to have somebody else's solution, somebody who does DR full time, to help you have that environment ready to go, to give you the technology and give you the tools to meet the objectives that your business needs.
Great.
So we're looking at the slide now.
Yeah, so I don't know if you've already covered everything on this slide, Mike, or if you want me to move on to
no,
the
actually,
next.
no, I'm glad that you have that in that slide there. So, you know, just to reiterate, you can have live servers in the cloud. We actually offer, we are a reseller of Riverbed. So both for WAN acceleration and load balancing, Riverbed acquired a company called Zeus. I really like their load balancers. I've been very impressed with how well they work. Riverbed acquired them, and they've gotten even better since that's happened. We can provide those as live running servers for you, take care of the licensing for you so that it's an OpEx instead of a CapEx for your company. And then also, let's say, for example, that you've got just an absolutely tight RPO. Like your business owners are saying, you know what, we need the fastest RPO possible. I don't care what it's going to cost. Well, for starters, under a solution like ours, cost of minimizing RTO is not crazy at all. It's very reasonable. We charge a very reasonable rate for RAM and storage. But second of all, you can leverage SQL replication, and that's actually how, from a database perspective, if you need the lowest RTO possible, SQL replication may be the way to go instead of block level replication, because SQL replication can be done very efficiently. Your database administrator usually knows how to make that happen, and it can get your RPO down into the sub 15-minute range if you need it to be that low. So there's a lot of approaches we can use, and I think one of the things to emphasize from nScale's perspective is that we're not trying to sell you one solution. We're trying to sell you your solution. We want to deliver to you what's going to make your company hit its objectives using our tools. And so that doesn't mean always using block level replication. We can leverage whatever makes the most sense to hit your business objectives. And again, I briefly covered this, the concept of client access, but just to briefly touch on it again, we have a lot of options for how your clients can get to the DR network, and this is all based on a scenario. Obviously, with the disaster recovery, there's a myriad of possible scenarios. We can provide you with VPN Tunnel Access, so you can have, for example, let's say you have MPLS and you want to have MPLS into our data center, but you want to have VPN to fail over to just in case something goes wrong with MPLS. That's a possibility. You can have client VPN access, where basically your clients can go home. Let's say that you want to have them just use the built-in VPN client for Windows or Mac OS. We've already got that covered for you. It uses radius authentication against your Cloud Active Directory domain controller. So that gives you the ability to log your users in. You can also provide, if you have a specific solution you like we have a customer who really likes Checkpoint, we can provide you with rack space to put your own VPN appliance in, and then that gives their users, for example, in this case, their users have the ability to just choose a different profile. So choose the disaster recovery profile for your VPN connection instead of the typical Office profile. There's a number of ways we can solve this. Again, as a part of implementation, we'll go over that with you.
Great. Michael, thank you so much for that material. As Mike mentioned, we do have a PDF technical solution brief on our website that you can download if you'd like to read more about this subject. We also have other materials in the same vein. We still have a couple of minutes to go in our allotted half hour, so if there's any questions, please type them into your GoToWebinar control panel. We haven't had too many questions come in, just the one or two I've asked already. So hopefully that means, Mike, that everything you said was perfectly clear to everybody.
Well, that's always good.
Yeah,
certainly if you wake up, in the middle of the night with a question, write it down and call me in the morning, okay?
Right. Let's see. Okay, David, it's not a question. David just says, good presentation. Thank you very much. Well, David, thank you for attending this morning or this afternoon, depending on where you are. It looks like it's just about 9 o'clock here in California, and I guess we're going to wrap things up. I want to thank everybody again for attending, and look for our next webinar a month from now. Thank you. Goodbye.